All right. We are reviewing for our tests. We are reviewing for our test. Question number 1. Which of the following represents a function and why? How do you know if something's a function? Jasmine? Cannot repeat the x values. So let's take a look. Does this one have the x values repeating? Yeah, you're out. This is, I don't know what they're talking about there. Let's see. Do the x values repeat right here? No, that's the answer. End of story. So here's the rule. Function equals no repeating x values. Question number 2. Which set of ordered pairs does not represent a function? What are you going to look for? You're going to look for repeated x values because now it says does not represent a function. Let's check out number 1. Look. Oh, the 3's repeat. It's choice A. End of story. Something's also a function if it passes the vertical line test. What does it mean to pass the vertical line test? It means you literally take a vertical line and you sweep it through. If it hits once, at each point it passes, like A passed the vertical line test. B passes the vertical line test. That one's good. Let's check out C. C passes the vertical line test. It's D that's not going to pass the vertical line test because, let me show you, that these two lines here, they're curving, right? So let me just draw them in a little bit more. They're curving. So you take your vertical line test and you sweep it through, and look, it's hitting 2 times. Right there and right there. That's what it means to fail the vertical line test. It hits twice at the same spot. So, which one of these guys is not a function? Obviously, it's D. D fails the vertical line test. Question number 3. Question number 4. Which of the following equation represents an onto function? Here's what it means to be onto. If you're an onto function, it means all the y values are used. In other words, there are no gaps in the range. In other words, there are no gaps for y when you graph it. And so I'm going to show you the answer. I'm going to show you I'm going to illustrate 2 of the multiple choices. Now the answer to the question is what choice? The answer to, how'd you know? Oh, I thought you guys were going to tell me the answer key is written on the back, just in case you didn't know. Okay. That's 1-to-1. If something passes a vertical and a horizontal, it's 1-to-1. But let's check this out. Let me show you something that is not onto. Not onto. Not onto. That is not onto. Not at all onto, right? Is anybody confused? No. That's what? Parabola. Is this onto? Oh, no. Good. Now let me show you something that's onto. So B is out. B is out. I'm telling you right now the answer to this question is A. You see that x cubed? People have also been asking me, how do you make x cubed? Right? You take x, take the caret button, and then you do cubed. And then check this out. Notice the difference. Every y value is used. It's completely covered. If you want to try and move your hand on the y-axis, you see how it corresponds to something on the graph?
What is that called?
Okay. That's called being onto.
No. It's
Yep.
not like this. Why is it like how it looks like that?
Question 5. Which diagram represents a 1-to-1 function? In order for something to be 1-to-1, it's got to pass both the vertical and the horizontal line test. Let me show you what I mean. What do I mean by vertical and horizontal line test? In red is a vertical line. Let's see if this thing passes the vertical line test. Yep, it passes the vertical line test. So now I'm going to break out my horizontal line test. Does it pass the horizontal line test? No, so you're out. Let's try again. Let's break this bad boy out. Let's try B. Sweep it through. Does B pass even the vertical line test? No, you're out. Let's try C. Oni, does C pass a vertical line test? Okay, so like by default now, what's the answer? Let me show you what I mean. Sweeping it through, sweeping it through, sweeping it through. It passes that line test. Now let's take the horizontal. Sweeping it through, sweeping it through, sweeping it through. Passes that line test. And so it's D. No. I understand what you're saying. You're being like, okay, like, look, it's hitting like a whole bunch of times. No, this graph is just a really bad picture. Here's really what it's saying. It's curving like that. And so when you sweep your hand Oh, that's annoying. And so when you sweep your hand through, right? And so, see? That's really what's going on. Like, look, we're sweeping, and so it passes. Question number 6, the function f of x equals 1 over x minus 3 is defined for all real numbers except what? What? It's defined for every real number except this one. Why? Because when you sub this number in, check it out. 3 minus 3 is 1 over 0, and this means it's undefined. Piece of cake? Right? Oh my God, our test is going to be so easy. Where'd this one? Question number 7 is something that people said they had a lot of trouble with. How do you figure out the domain? Well, there's 2 roots. Ben, what's one root? Yeah, it's square root. So stuff underneath, right? Stuff underneath has got to be greater than or equal to 0. So this is basically what goes down. We got x minus 6 is greater than or equal to 0. You add 6 to both sides. Ben, is this what you were going to do? That's okay. You could do it in your head. X has got to be greater than or equal to 6, and so what choice is it? Done. End of story. End of story. End of story. Morning glory. Right? So here's another way. So some people are not so good with figuring this stuff out. Break out your calculator. Break that thing out. Turn it on. Right? Graph it. We can't really see what goes down here. Type in the equation x minus 6, right? And then you could take a look at the graph, right? Or you could just take a look at the table of values. What's easiest for you guys? Table of values, and we're going to go into our table of values and look. Error, 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 error. You know, it's got to be bigger than 6, and then stuff starts to work. So hence the answer is C. Here we go. Question number 8. How do we find the range? What's the range again? Yeah, the range of the y values. So check this out. All I'm going to do is plug this in. Negative x squared plus 9. And first thing I'm going to do is I'm going to print up a graph. So the y values for this graph, look, are less than that number, right? They're less than that number. So, I mean, you could count. So it's got to be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now, sometimes you can't count like that, but it looks like it's got to be less than 9, right? Is there any choice up here where y is less than or equal to 9? Yes. Which choice? This is easy, right? Anthony goes, how do you do that algebraically? You can't do the range algebraically, at least in this class. To figure that out, that's a pre-calculus advanced concept. The domain, like the last problem, can be done algebraically because it's very simple. The range for us will have to be something that you look at on a graph and try and interpret. So now we reach the hard part. For the graph below, state the domain. The domain are the x values. So you just take your hand and you stretch it across, and what does x have to be? Less than 2, but it's got to be greater than or equal to negative 2. And you could say it this way, or, right, you could say hard bracket because of the circle, because of the filled in circle, negative 2, comma, soft bracket because of the open circle. So here's the hard part. Now we got to try and figure out what the range is. So you're going to take your finger, right, the range of the y values, and you're going to start at its lowest point, right? Negative 2. Let me pick a different color. Negative 2 is less than or equal to, because negative 2 is filled in. Now you take your finger and you move it up until the graph stops. Now it stops right here, right? But we have a problem in that right over here, check, whoops, right over here at 0, it's open and it's closed. And if it's open and it's closed, you take the closed one. Okay? So that means that the range goes from -2 to 0. Because although it's open, it's filled in also as well. Right there. And you could say that as hard bracket on -2 and hard bracket on 0. Okay. Part C, you got to determine whether it's a function or not. How do you know if something's a function? Yeah, so you take your vertical line, you sweep it through, does it pass? And you literally have to write yes because it passes the, and we're not going to abbreviate this time because it's a test, the vertical, and my handwriting really sucked, line test. And that's it. That's the complete answer to that question. All right, problem number 10. This is what's called, what? Evaluating functions. I want to know what I want to know what this is. So all you do is just plug it in. Plug it in, plug it in. Love that commercial. Right, we're going to plug it in for x. And then you solve it, and so it's going to be like a plus 4 over a. Question number 11, same idea, but instead of using variables, a variable expression, we're going to use numbers. And the reason that I chose this is because I want you to remember how to plug in. If there's a negative number, you have to put that in parentheses, or else your calculator's really going to mess it up. Now let's do this math without a calculator. -2 squared is what?
4.
And what's 4 plus -12? What's -8 plus 9? Good. The bottom. What's 4 minus 9? Question number 12. Now we got to evaluate functions graphically. How do you find the value of f at -2? Well, this, remember, I told you, whenever you see this, you put parentheses. This goes in the x spot, and so you're looking for the value of the function at -2. -2, it's right there. It's trace. Oh my God. Question number 13. Looks really difficult. In fact, it's really not. Right? The first thing I'm going to do is I'm going to find the value of f at 2. F at 2, this right here, is the same thing as me plugging in to this equation, right? F at 2, that's like 2 times 2 squared minus 2. Okay? And let's find the value of that. That's 2 times 4 minus 2. So what is that? So that's 6. So really, f at -2 is 6. So right now we got 6 minus. We got to figure out what what this is. Right? How much is this worth? That's 2 times -2 squared minus -2. Minus 2 is plus 2. And so what's a plus 2? So 10. So that's how much this is, right? And so really, this red equation over here is the same thing as saying 6 minus 10, which is -4, which is a.